In the autumn of 1927, a sculptor stood at the base of a granite mountain in South Dakota, with no road to the top, no power line within miles, and no safe way to get a single man onto the cliff. Electricity first arrived through a diesel generator, borrowed from a Chicago utility magnate, a machine so temperamental it required 2 men just to keep it running, and it eventually exploded. The power that replaced it came from a gold mine sliding into bankruptcy, which handed the project one of its compressors on the way down. And for a while, every Monday morning, the drills on the mountain would slow and die because half the town of Keystone was running its electric washing machines, and there was simply not enough current left for both. That is the strange, improvised, deeply human story of the machinery behind Mount Rushmore. The mountain the Lakota called the Six Grandfathers had already been taken from them before a single charge was ever set, and the men who came to carve it were working with borrowed equipment, pine trees stripped bare and stood up as utility poles, and diesel fuel shipped in by rail from Casper, Wyoming. Nothing about this project was orderly. Nothing was well-resourced. The reality was chaotic from the first morning to nearly the last. But the single most important piece of equipment on that mountain was not a compressor, or a stick of dynamite, or a jackhammer weighing 75 pounds. It was a measuring device borrowed from the sculptors of ancient Greece, scaled up exactly 12 times, and without it, none of the 4 60-foot faces could have existed in any recognizable form. It translated a 5-foot plaster model sitting in a studio into a carved granite face the size of a 6-story building, using nothing more than an angle, a distance, and a drop. It stands as one of the most genuinely overlooked pieces of engineering in American history. During the next 30 minutes, we will walk up that mountain machine by machine, from the compressor building at the base to the Greek trick at the top. We will stop at the power failures and the forge, and the teenagers shouting commands into the wind, and we will end at the device that made the whole thing possible. Stay with us, because the most important machine on that mountain was not a drill or a stick of dynamite, and almost nobody who has ever stood in that parking lot and looked up has any idea it existed. The reason anyone pointed a drill at this particular mountain had nothing to do with art and everything to do with money. In the early 1920s, South Dakota was a state that tourists passed through on their way to somewhere else. The Black Hills were scenic enough, but scenic does not fill hotel rooms or move goods off train platforms, and the state knew it. The man who decided to do something about that was a historian named Don Robinson, who worked for the South Dakota State Historical Society and spent a good deal of his time thinking about what it would take to get people to stop and spend. His idea, which he began pushing in 1923, was to carve heroic figures into a dramatic cluster of tall, narrow granite spires in the southern hills called the Needles, figures from the American frontier, men like Lewis and Clark, guides like Sacagawea, chiefs like Crazy Horse and Red Cloud. The carving would become a destination. The destination would bring dollars, and the dollars would mean something to a state that badly needed them. Robinson needed a sculptor capable of working at a scale that had never really been attempted before. The sculptor he found possessed an ego as vast as any peak. His name was Gutzon Borglum, and he arrived in South Dakota trailing a long and complicated history. He was the son of Danish immigrants, had trained in Paris under Auguste Rodin, had built a national reputation carving large-scale figures for powerful institutions across the country. He had also feuded with nearly every commission, committee, collaborator he had ever worked with in nearly every city where he had left his mark. Borglum was imperious and difficult and absolutely certain of his own judgment. That was both the problem with him and, as it turned out, the reason the mountain looks the way it does. Upon visiting the Needles, Borglum determined the granite was too thin, too fractured, too unstable for such demanding carving. He looked elsewhere, and his eye landed on the southeast face of a broad granite wall that caught the most sun during the day and shed ice faster than the slopes around it. The mountain had no name when a New York lawyer named Charles Rushmore passed through in the 1880s, reportedly asked what it was called. When he was told nobody had given it one, he suggested his own, and it stuck. Borglum told Robinson to forget the frontier figures. He was thinking of something national in scope, and he chose 4 presidents to carry that idea. Washington for the founding of the country, Jefferson for the Louisiana Purchase. That had opened the continent and had, in a direct geographic line, produced the very state they were standing in. Lincoln for holding the nation together when it tried to come apart. And Roosevelt for the moment America stepped onto the world stage and announced it intended to stay. There is one fact underneath all of this that deserves to be said plainly. The Black Hills had been guaranteed to the Lakota people in the 1868 Treaty of Fort Laramie. Discovery of gold in the hills during 1874 saw that guarantee collapse under the weight of the rush that followed. By 1877, the land had been seized by the federal government. Hold on to that, because the granite Borglum was about to carve had already been taken from someone before the first charge was ever set. Everything that happened on that cliff depended on 3 air compressors sitting inside a wooden building at the base of the mountain. Compressed air was not a convenience on Mount Rushmore. It was the blood of the entire operation. Those machines drove the drills, powered the finishing tools, and kept every man on the rock face doing something useful. When they fell silent, the mountain stopped. And in 1927, keeping them running was a problem that nobody had fully solved before the first charge was ever set. There was no power line anywhere near the Black Hills when work began. The nearest reliable electricity was miles away, and the terrain between the mountain and any useful infrastructure was not cooperative. So Borglum did what the whole project would do again and again across 14 years. He improvised. A Chicago utility magnate loaned the project a 3-cylinder diesel generator, a large and temperamental machine that was set up near the railroad depot in Keystone, roughly 3 miles from the base of the mountain. Getting fuel to it was its own problem. The diesel had to be produced in Casper, Wyoming, and shipped in by rail, then hauled overland to the depot. To carry the electricity from Keystone toward the mountain, the crews stripped the branches off pine trees, stood the bare trunks upright, and strung the power lines from trunk to trunk across the hills. It was not elegant. It worked, after a fashion. The generator required 2 men working full-time simply to keep it running, coaxing it through each shift, and in the end it repaid their efforts poorly. The machine exploded, injured one of the workers, and was abandoned after that first year. The project moved on and found its power somewhere else entirely. The replacement came from the Keystone Consolidated Mines, a gold operation whose plant sat near the Holy Terror mine. And here the project's bad luck and good luck arrived together, because the mining company was failing. When the Keystone Mill burned around 1930 and the company slid into receivership, it handed one of its compressors over to Mount Rushmore on its way down. The monument to 4 presidents was being equipped, in part, with the salvaged machinery of a dying gold mine. Even after the power situation stabilized, it kept producing new problems. The most maddening of them surfaced every Monday morning like clockwork. The drills on the mountain would slow and then quit, and for a while nobody could explain it cleanly. When the National Park Service sent engineer Julian Spots to the site in 1936 to bring order to the operation, he traced the failure to its actual source. Nearly every household in Keystone did its laundry on Monday, and a great many of those homes now had electric washing machines. The combined draw from an entire town running its wash at once was pulling enough current that the mountain came up short. Rather than rearrange the domestic habits of Keystone, Spots commissioned a gasoline-powered auxiliary compressor, which more than doubled the number of jackhammers that could run simultaneously. Spots had a sharp eye for waste in general, and the laundry problem was not the only thing he found. He caught the site blacksmith quietly tapping into the compressed air pipeline to blow cooling air on himself while he worked at the forge. It was a small theft of pressure, but pressure the drills above needed. Spots replaced the tapped line with a simple fan, and the leak was closed. These are the kinds of details that never make it onto the bronze plaques, but they are the actual texture of how a mountain gets carved. The permanent answer did not arrive until 1939, when a proper power line finally reached the site and supplied the electricity for the last 2 years of work. Getting a man onto the face of the mountain was its own engineering problem, and the solution looks almost unbelievable in the old photographs. Before a single drill touched granite, every worker climbed 506 steps and 45 ramps to reach the top of the mountain. That is the rough equivalent of a 40-story building, and the men climbed it at the start of every shift, on their own time, unpaid, because the working clock did not start until they reached the summit. By the time a driller sat down in his Bosun chair for the first time each morning, He had already spent a significant portion of his physical reserves on a staircase. The tramway that ran alongside those stairs was originally built to haul tools and supplies, not men, and for a long stretch of the project it was not rated to carry a human body safely. It would eventually be reinforced and fitted with an emergency brake by Julian Spots during his 1936 reforms. But for the early years, the stairs were simply what you climb. The Bosun chair itself was a small leather swing seat, not much more substantial than a playground swing scaled up for an adult. From that seat, a man was lowered on a steel cable 3/8 of an inch thick, roughly the width of a finger, down a cliff face that dropped away 500 feet beneath him. Borglum designed the leather harnesses himself. 6 large hand-cranked winches sat at the summit, and the men operating them raised and lowered the workers dangling below. There was no motor, no hydraulic assist. A man at the top turned a wheel by hand, and another man swung out over open air. Call boys were often teenagers. They sat at the edge of the cliff in the open air, in the wind, and they shouted commands back and forth across the gap between the man on the cable and the man on the crank who could not see each other. Faster, hold, bring him up. The wind off the Black Hills could swallow a man's voice whole, and the call boys shouted into it all day. This was the nervous system of the entire operation, a human communication relay strung between 2 men who had no other way to work together. The tramway had its own chapter in the near-disaster record. At some point during the project, a cable car broke loose and ran away down the mountain, building speed before it slammed into the lower station and put a man in the hospital. It was the kind of incident that could have been fatal, and was not, by a margin too thin to feel comfortable about. That margin repeated itself, in different forms across 14 years of men hanging on cables over a 500-foot drop, teenagers shouting into the wind, and machinery that failed and was repaired and failed again. The perfect record of no deaths was not luck alone. It was the narrow margin by which 100 small disasters were survived, one after another across 14 years. More than 90% of all the rock that ever came off that mountain was removed with dynamite, and the men who did it were not trained sculptors. They were ex-miners, most of them. Men who had spent years underground in the gold and tin operations of the Black Hills, and knew from hard experience how rock behaved when you asked it to move. Names like Red Anderson and Hoot Leach appear in the accounts, men who understood the difference between a seam that would shear clean and a fault that would shatter everything around it. Borglum did not find this skill in an art school. He found it at the bottom of a mine. The schedule was fixed, and it never varied. Twice a day at the lunch hour and at 4 o'clock when the shift ended, every man came off the face. The mountain belonged to the powdermen then. They moved across the granite in the quiet, placing their charges, and when they were satisfied and the last man was clear, the fuses went. A single round could involve as many as 70 separate charges, each one a stick of dynamite cut to a precise length, set in a drilled hole, and calculated to remove a specific volume of stone. The rule of thumb Borglum's crews worked by was roughly 1 pound of dynamite to 1 cubic yard of granite. That sounds simple. The execution was not. What made this genuinely remarkable, and what most accounts fail to convey, is the tolerance they were working to. Those charges were being set on a mountain face that would eventually resolve into the skin of a human cheek, the bridge of a nose, the curve of an eyelid. The powdermen were blasting to within 3 to 6 inches of a finished presidential portrait. That margin, 3 to 6 inches, is not much distance when you are working with high explosives on hard granite at altitude. One charge cut too deep, one seam running the wrong direction through the rock, and months of careful geometry could disappear in an instant. And that is exactly what happened with Jefferson. His face was begun to the right of Washington, and the work went on for months, but the granite there was running with fractures the surface had not revealed. Cracked and unreliable stone that would not hold detail and could not be trusted to stand. Borglum made the decision to blast the whole section off and start again, all of it. Then he moved Jefferson to Washington's left side, which forced Lincoln to shift his position in the composition as well. Borglum revised his model 9 times across the life of the project, because the mountain kept presenting him with rock that did not match what he had planned for. After each blast, when the cloud of granite dust had drifted down into the valley below and the air had cleared enough to see, Borglum would study the fresh stone against his model. He was looking for what the rock had given him and what it had taken away. Sometimes the break was clean and the geometry matched. Sometimes it was not, and the model would come out again, and the measurements would shift, and the powdermen would receive new instructions. This back and forth between the sculptor and the stone went on for 14 years. The dynamite work was not raw or crude, though from a distance it must have looked that way. There was genuine precision being practiced on that cliff, worked out through experience and repeated failure, and a close reading of how the granite split under different charge sizes and orientations. A charge placed at the wrong angle in the wrong density of rock did not remove what you wanted it to remove. It removed something else. The powdermen learned to read the face the way a good woodworker reads grain, understanding where the material wanted to go and shaping the blast to follow it. 450,000 tons of granite came off that mountain in this way. And when the dust finally settled for the last time, what remained was within inches of 4 human faces. What stands before you today is not the original conception. It is what the stone ultimately chose to allow into being. Granite ranked among the Earth's most resistant minerals, and it ate through drill bits at a rate that made the forge at the base of the mountain as essential as anything bolted to the cliff. Every few hours, a worker called a steel nipper would climb down the face in a harness, moving from man to man along the rock, collecting the dull bits and leaving sharp ones behind. A driller stranded without a usable bit was a driller wasting time and cable, and a bosun chair position that another man could have used. So the nippers moved constantly, up and down that cliff face, ferrying steel between the men hanging in the open air and the blacksmith working below. That blacksmith, at his forge at the base of the mountain, was retempering and resharpening bits at a pace that sounds almost impossible until you understand how quickly granite destroys cutting edges. And the quality of that work was not an abstract concern. A poorly tempered bit did not simply go dull. It shattered inside the hole, and a driller with a broken bit embedded in granite mid-shift had no good options. A well-tempered one held its edge long enough to matter and kept the stone moving. The forge was not a support operation, it was a production line, and it ran all day. The air that drove the drills had its own infrastructure, and it is worth pausing on, because 1,800 feet of 3-inch steel pipe running from the compressor building up alongside the stairway to the faces is not a small thing to picture. That pipeline was the circulatory system of the whole upper mountain. In cold weather, a fine mist of liquid antifreeze gas was injected into the line just past the compressors to keep the pipe from freezing solid in the Black Hills winter, which could reach temperatures that would shut the entire operation down in an hour. As more drills were added across the years of construction, the pipeline itself had to be enlarged to carry the additional volume of air. It grew with the project. The tools at the end of that pipeline were Chicago pneumatic jackhammers, and they ranged from roughly 45 pounds for lighter assignments up through 75 or 80 pounds for the heavy drilling. On flat ground, a 75-pound pneumatic hammer is a hard day's work. In a bosun chair hanging 500 feet above the valley floor with nothing solid beneath your boots, it is something else entirely. The natural behavior of the tool was to dance and wander across the rock, pulling the bit offline. A man on solid ground can brace against that with his weight and his footing. A man suspended in open air has no footing at all, so the drillers worked it out for themselves. They learned to position themselves with heels pressed together and feet angled outward, resting the bit in the narrow V between their boots, using the leather and the steel of their own shoes to guide the drill where they needed it to go. For the rarer horizontal cuts, where the recoil pushed the man directly away from the rock, they drilled 2 angled holes first, drove a short chain into them, and pressed their bodies back against that chain to hold position while they worked. These were not innovations specified in an engineer's blueprint. They were habits worked out by men hanging on a cliff who needed to stay alive and keep the stone falling. Now we come to the most ingenious solution across the whole undertaking, and the one that made everything else possible. Think about the problem Borglum was actually facing. Within his workshop positioned at the mountain's foot, he had a plaster model of each presidential head standing roughly 5 feet tall. He needed to produce the same face at 60 feet. No computers, no lasers, no photographic projection system of any kind. Just a man, a mountain, and the need to translate every curve of a cheekbone and every hollow of an eye socket from a 5-foot object to a 60-foot wall of living granite without losing a single proportion in the transfer. The geometry alone is enough to make your hands go still. 1 degree of error on the model becomes 12 degrees of disaster on the cliff, and a face that reads as human from 500 feet away is separated from a face that reads as wrong by margins that would fit inside the width of a man's palm. The solution Borglum reached for was not modern at all. It was Greek. Sculptors in the ancient world had long used a pointing method to enlarge or copy a figure in stone, a system built around a fixed center axis and 2 measurements taken from it. Borglum adapted it, scaled it, and turned it into something that could be read by workers hanging in Bosun chairs on an open cliff in the Black Hills wind. On top of each plaster model in the studio, Borglum mounted a flat protractor plate, like the kind a draftsman might lay on a table, but oriented horizontally so it sat level above the sculpted head. From the center of that plate, a steel bar extended outward, mounted so it could swing in a full circle, like the hand of a clock sweeping the face. From the end of that bar hung a plumb line on a sliding pin, a weighted line that could be moved in or out along the bar's length. 3 numbers defined any point on the model's surface. First, the angle of the bar, how far it had rotated around the center. Second, the distance out along the bar, how far the plumb line had been slid from the axis. Third, the drop, how far down the plumb line descended before it touched the surface of the plaster. Angle, distance out, drop. Those 3 numbers, taken together, could locate any point on the model with the precision of a watchmaker. And then the same device was built 12 times larger and anchored on each of the 4 heads on the mountain. The same angle on the mountain version corresponded to the same angle on the studio version. The distances, multiplied by 12, a measurement of 3 inches on the model became 3 feet on the granite. The workers who carried this translation up the cliff were called pointers, and their job was to take the readings off the studio model, climb the staircase, and go out on the rock face and find the corresponding point on the mountain, then mark it in red paint so the drillers knew exactly where to cut and how deep to go. Thousands of these readings were taken. The whole transfer was built on arithmetic and patience and the steady nerve of men willing to make their calculations while hanging above a 500-foot drop. But here's what the pointing machine could not do. It could tell a driller where to cut and how far, and at what angle. It could not tell him how to cut a human eye so that it reads as alive and not as a hole in a cliff. That problem belonged to a man named Luigi Del Bianco, the chief carver, a stone carver trained in Italy who had worked the Pietra di Istria, a famously hard limestone, before he ever crossed the Atlantic. He earned $1.50 an hour on the mountain at a time when a general laborer earned $8 for a full day. The rate was a measure of what he could do that no machine and no pointer's arithmetic could replicate, which was to give the planes of a face the quality of thought behind it. Del Bianco worked the eyes particularly, carving the irises and the subtle undercutting of the lids that makes a stone head seem to be looking at something rather than staring past it. For decades, he went nearly unmentioned in the official history of the monument. The Park Service formally recognized his contribution only in 2016, 75 years after the project closed. The pointing machine set the geometry of the mountain. Del Bianco gave that geometry something the protractor and the plumb line could never measure. Once blasting reduced the rock to just a few inches above the finished surface, the whole nature of the work changed. The blaster stepped back, and a different kind of worker moved in with a different kind of tool and a different kind of patience. The method they used in this phase was called honeycombing, and the name is exactly right. Using pneumatic jackhammers, carvers drilled dozens of small holes into the granite in a tight, closely spaced grid, hole beside hole, across the surface that the dynamite had left behind. The idea was not to remove the stone directly, but to destroy its internal structure first. Once enough holes were packed into a small area, the granite between them lost its ability to hold together, and the remaining material could be knocked away by hand or pried off in chunks with a simple chisel. The technique allowed carvers to take the rock down to within an inch or 2 of a finished presidential cheekbone without cracking it. That distinction mattered enormously, because at this stage there was no replacing a mistake. A bad blast could be compensated for by adjusting the model. A crack running through Lincoln's forehead could not. After honeycombing came what the workers called bumping, and if honeycombing required patience, bumping required something closer to surgical restraint. The bumper was a light pneumatic hammer, far smaller than the heavy jackhammers used for rough drilling, fitted with a steel shaft, tipped with short hardened points. It chattered against the stone rather than pounding it, taking down fractions of an inch at a time, smoothing what the honeycombing had left ragged. The surface that came off a well-worked bumper was described by those who saw it as smooth as a concrete sidewalk. When you stand in the viewing area today and watch afternoon light move across Washington's cheek, that texture, that quality of stone, is what the bumper tools left behind. It is granite that has been argued with inch by men hanging in leather harnesses over a 500-foot drop. In the early years on the mountain, the drilling was dry. No water injected into the drill holes, no suppression of the dust that granite throws when steel strikes it at speed. The compressed air that powered the drills also blew the cuttings out of the holes and into the air, and into the lungs of every man working on that face. At the end of a shift, workers used the same compressed air hoses to blow granite dust off each other before climbing down. It worked well enough on their clothes. The scale of what silica dust does to human tissue was not invisible to the world in those years. In West Virginia, beginning in 1927, workers drilling the Hawk's Nest Tunnel through Gauley Mountain were breathing concentrated silica dust in an enclosed space, and they began dying. The estimates of how many died vary widely, but credible figures start at 764 and run considerably higher, with some researchers placing the toll well above 1,000. Silicosis filled the lungs with scar tissue so slowly and so completely that men who felt fine at the end of a working season were dead within a few years, and many of them were young. That disaster became known. Awareness of the hazard grew. Wet drilling, which suppressed the dust by injecting water into the drill holes, came into broader use. On the mountain, as the years went on, practices improved, but the early dry years had already happened, and the men who worked them had already breathed what they breathed. The official construction record at Mount Rushmore shows no deaths. That is true, and given what was happening on that cliff every working day for 14 years, it is genuinely remarkable. The official count of no deaths during construction is true and remarkable. What remains hidden in such accounting is the sickness that certain of those workers brought back deep inside their bodies, and that silence is its own kind of fact. Money was the other mountain, the one that nearly stopped the real one again and again. The Great Depression settled over the project almost from the beginning, and what it meant in practical terms was this: short working seasons, gaps of months where nothing moved, men let go without ceremony and rehired when the next appropriation came through. Congress had agreed to match private donations up to $250,000, but the private donations dried up in the early 1930s almost completely, and the federal money had to carry the weight alone. By the time the last drill went silent, the project had cost just under $1 million, and roughly 85 cents of every dollar had come from the federal government. The mountain that was sold to the public as a monument to democracy was funded, in the end, almost entirely by the state. Borglum made none of this easier. He quarreled with the Mount Rushmore National Memorial Commission with the same energy he brought to everything else, and the commission's records from those years read like the transcript of a marriage that should have ended much sooner. He fired workers without warning. He spent money the commission had not approved. When President Coolidge came to South Dakota in the summer of 1927 and agreed to write an inscription to be carved somewhere on the mountain, a text that would explain to future visitors what country had built this thing and why, Borglum accepted the assignment, read what Coolidge submitted, rejected it, told the commission he would write it himself, and never produced a single line. The text was never carved. The mountain has no inscription, and then there was the Hall of Records. Borglum had carried this idea since his earlier work on Stone Mountain in Georgia. Behind the carved faces, hidden inside the canyon wall, he wanted a great vaulted chamber, a room large enough to hold the founding documents of the country, the Declaration, the Constitution, the history of the nation written in a form that could survive whatever came next. He was not thinking small. He imagined a stairway cut into the canyon wall, a grand entrance, a room that would make a person understand the scale of the ambition behind the four faces above. Blasting on the Hall of Records began in July of 1938. Workers cut a tunnel 70 feet into the granite behind Lincoln's head before the money and the attention shifted toward a war in Europe that was no longer easy to ignore. The appropriations that might have continued the tunnel were redirected. Borglum pushed for it until he could no longer push for anything. He died in Chicago on March 6, 1941, of complications following surgery at 74 years old. His son Lincoln, who had worked beside him on the mountain for years, took over the site and did what he could with the money that remained. On October 31, 1941, he closed the site for the season. A few weeks later, the Japanese Navy reached Pearl Harbor, and the money for South Dakota mountain carving did not come back. The Hall of Records sat as an unfinished, unmarked tunnel for the rest of the century, known to almost no one, visited by no one. A 70-foot hole in the granite that the postcards never showed. It was not until 1998 that the Borglum family and the National Park Service returned to it. They installed a titanium vault in the granite floor of the unfinished chamber and filled it with 16 porcelain enamel panels carrying the text of the Constitution and other founding documents. It is sealed now behind a granite capstone. There is no public access. Most visitors standing at the viewing terrace have no idea it is there. What those 14 years of work actually produced, measured in stone, is worth saying plainly. Washington's nose runs 20 feet from bridge to tip. The faces are visible on a clear day from 60 miles away. The granite beneath them erodes at roughly 1 inch every 10,000 years. And in 1980, the United States Supreme Court ruled that the seizure of the Black Hills had been illegal and offered the Lakota Nation more than $100 million in compensation. The Lakota refused it. That sum has been accumulating interest ever since, and now sits past $1 billion untouched because the position of the Lakota has not changed and is not likely to. The land was never for sale. More than 2 million people visit every year and look up at 4 presidents in stone. And almost none of them know about the protractor and the plumb line and the simple Greek idea multiplied by 12 that made every one of those faces possible, or the men who ran the machines for $8 a day, and what some of them took home in their lungs when the season closed.